and we're going to reference it in a second. This is section 2.1, maximums and minimums. I'm waiting for you. I already know this. I have my 3 degrees. Let's go. Copy this down, please. This is section 2.1, maximums and minimums. Tonight's homework is page 18. We're going to do 76 through 87. Please copy this website down, www.desmos.com. You may have heard of it before. It is a website that you need to be able to access at home. So it's on your phone, on your iPad, anywhere where you have Wi-Fi. It's actually an app as well, because this is in lieu of, what does in lieu of mean? In lieu of, huh? Oh, connected with, that's a great guess. Instead of, this is instead of buying a graphing calculator. So in lieu of, which means what? Instead of buying a graphing calculator, you're going to use this website. So please write it correctly, DESMOS.com. If you have an iPhone, there's an app called Desmos. If you have a, what's the other one? Android. The other one, you can also download the app. I'm going to give you about 15 more seconds to copy all of this down. Example 1, and then we're going to reference it in a second. Use your colors, please. This is in color. You need to put it in color. Put your pencils down. That's how I know that you are ready to proceed. Jacob, please don't fight me good. I need that graph to be in color. Thank you. There. Now take out your books, your homework books, and open up to last night's homework, because we did have some discrepancies on last night's homework. Please turn to page 15 in your books and then hold it up so that I can see you're on the right page. Page 15 in your books. It should look like this. Emilio, you need to bring your book every day, please. Share with somebody in your group. Page 15, let me see it. You need to bring it every day. Share with somebody in your group. Group 1, hold it up, please, so I know you're on the right page. You're on the wrong page, sweetheart. Page 15. You guys, can you show her? Because she's on the wrong page. All right, great. Let's take a look at number 64. And you will notice that number 64 is this bad boy right here. So let's go ahead and put that into Desmos. Let me show you what that's going to look like. This is what you will be expected to do tonight. Last night I asked you to plug in Fab 5. And a lot of us had a little bit of trouble with that. I did get a lot of messages on Remind about that. So I want us to take some time this week to really practice in plugging in our Fab 5. So what we're going to do is we're going to take a step back, and we're going to use Desmos tonight. And I'm going to show you how to use Desmos to answer your question. Okay? Camden, do me a favor. For number 64, can you please read us the directions? And then I'm going to ask 2 more people to read it out loud, so you need to read along with him. Go ahead.
Choose the graph that represents each function using
Using your what? All right. Ben, can you read it one more time?
Use the graph that represents each function. Use your graphing calculator.
We're going to use a graphing calculator. What are we going to use, Jeremiah? Read it again.
Choose the graph that represents each function using the graph.
All right, pretty simple. So that's why we're going to be using Desmos unless you have a graphing calculator. Raise your hand who has a graphing calculator. Yeah, that's what I thought. We don't have one because they're like 90 bucks and we're not ready to have one in here. But if you buy one, that would be awesome because you're eventually going to need it in Math 2 and Math 3. But for now, we can use Desmos because it's free and we like free stuff. Oh, you have one. Nice, Jeremiah. All right, so Jeremiah can use his graphing calculator. The rest of us are going to download Desmos on our phone, or we're going to go to the iPad and go to www.desmos.com or our computer. Raise your hand if you do have Wi-Fi access at home.
I use my mom's phone.
Okay, can you use your mom's phone maybe?
Yeah, her hotspot.
That's fine. Okay, why are we laughing? All right. Now, do you guys see number 64 up here? This is number 64. Do you guys see how it says 2/3 x plus 2? Say yes or no. Do you see it?
Yes.
All right, Luisa, are you ready? I'm going to teach you how to put this in to Desmos. Let's start over. What you're going to do is you're going to go to the empty one and you're just going to press parentheses 2 divided by 3. Then you're going to close the parentheses. Then you're going to get out of the parentheses x. And then what does it say? 2/3 x plus?
Yes.
Plus 2. And then there's your graph. And all we have to do is look at the book and see which of the graphs looks like this. All right. What I need you to do is, you guys, he doesn't have his book, so somebody needs to share with him. You should be looking at your book right now and saying, okay, this looks like either graph A, B, or C. Look at your book. And which graph does this most resemble? I see one hand. 2, 3, 4, 5, 6, 7, 8, 9, 10. Hannah, give it to me. Graph A. So tonight, just for tonight, because I know we need more time with the Fab 5, I'm going to give you another night to finish last night's homework by using Desmos. So what I'm asking you to do is go back, use Desmos, and then for number 64, you're going to put graph what? Graph letter what?
A.
Graph A. Because you put it in Desmos. Okay? All right. Yes, Jason?
What if I already did it?
I know, but you got to check it on Desmos now.
Okay.
Okay? You must check it on Desmos because sometimes we do the homework and then we're like, oh, actually, it wasn't right. And that's perfect way to check it is on Desmos. Okay? All right, letter B. I'm sorry, number 65 is this one right here. Negative x squared plus 4. It's easy when you see Miss Riad put it in, but I need to teach you how to put that in your Desmos. You guys see the keyboard down here? Say yes or no. Do you see it?
Yes.
You're going to need this keyboard for special keys. So if I want to put in negative x squared plus 4, I just put the minus sign, I put the x, I want to square it, and then I put plus 4. Pretty easy? And then I can exit it so I can see my graph. When you're ready to tell me which graph it most resembles, raise your hand. Great, I have all hands up. I love to see that. JJ? Graph B as in boy? But graph B as in boy. Agree or disagree?
Disagree.
Disagree? Jose?
Graph C.
Graph C? I would say graph C. Look, graph B, JJ, doesn't B go like this? Is that what this does? JJ? Does our graph go like this, like graph B? What does it look like? Which one is it now? It is C. All right? So tonight you're going to put number 65. What are you going to put? Graph C. Okay? So now you can double check last night's work and see if you got it right. Okay? A lot of us are like, but I did it using the Fab 5. Now you're going to check using Desmos to make sure you got it right. The last thing I want to show you is how to put in 2 to the x plus 5, which is our number 66. This is number 66. When you're ready to tell me which one it resembles, raise your hand. Jameson, which letter does it most resemble?
B.
B as in boy? Agree or disagree?
Agree.
Nicely done. So you're going to put number 66, letter B. But let me teach you how to put this in your computer. Ready? What do I need?
Keyboard.
The keyboard. Good job. So I need the keyboard because I'm doing exponents in special cases. Camden, watch. You're going to put 2. Then you're going to put this right here because that means you want an exponent. Can you guys see what button I'm looking at right now? Can you guys see that button? You're going to use this one right here. A to the B. Then 2, and then you're going to put an X. Then you're going to get out of it, and then 2 to the X plus 5. Okay? Yes, babe.
Type in X or you just click the X button?
Either one will work. Yeah, I prefer to use the X button, but it doesn't matter. What do you guys think? Does Desmos look scary?
No.
Okay, so we can all use it. We don't feel scared with Desmos, right? It's something I could totally use, right?
I'm really scared.
You're scared? That's okay. You can come in at lunch if you want it. We can work on it together. Okay? All right, any questions on what we're doing tonight? So on Monday, I will be stamping this, which was last night's homework, because we're all going to go on Desmos and check it. And I'm going to stamp tonight's homework. Okay? All right, let's take a look at tonight's homework. Gentlemen, have a seat. Now we're going to go back to our notes. And we're going to talk about something new about our graphs is when there's a maximum and when there's a minimum. These are words we've heard before. 30 seconds in your group. Make sure everybody in your group understands what is a maximum and what is a minimum. Talk to each other. All right. We're going to talk about the maximums and the minimums of our graphs. Is everybody with me? All right. Now I want you to think of words, other words that would help you describe a maximum. Like if a 4th grader walked in here right now and you couldn't use the word maximum, how would you be able to describe a maximum? 1 hand, 2, 3, 4, 5, 6. Oh, good. I love that you can describe it. Jeremiah? How would you tell somebody something's a maximum?
The highest point.
Highest. I love that word. What's another word, Moses? The top. Okay, I like that. Amelia? The peaks. Good. Jason?
The greatest.
Greatest. See, these are all awesome words. Those all mean maximums. Give me minimums now. Think of a word for minimum. Jameson?
Smallest.
Smallest. Ben?
Lowest.
Lowest. Jacob?
How about I say lowest?
Lowest, smallest. Sometimes it's decreasing, but it's still can be a maximum. Yep.
Shortest.
Shortest. Okay, I'll kind of take that. Okay, those are all great words. Did we say lowest?
Yes.
We did. Okay, so those are the words to describe a minimum. All we have to do today, guys, please don't make it harder than this. All we have to do is identify if some function or some graph has a maximum or a minimum. Okay? That's it. That's what we're doing today. The second part of today's homework, God bless you, is what we've already done is you're going to be describing if something's increasing or decreasing, which you guys have mastered. Everybody in here is really good at describing to me when something's increasing and when something's decreasing. Okay? So let's go ahead and take a look at example 1. We want to make sure that we are able to identify if something has a maximum or a minimum. So this is what you're going to imagine. You're always going to start from the left, just like when you're reading a book. When you're reading a book, do you get to pick and choose where to start reading?
No.
No, it's not like I read from right to left and you get to read from left to right, and some people read top to bottom. That's not how it works. Universally, we all decided to read from where to where? From top? From left to right. We start here and here. So that's how we're going to read a graph too. When you read a graph, you always read from left to right. You don't start from the top and read from the bottom. You don't start from the bottom, you don't do that. You start from here and read the graph. So what, really, we're going to stare at the door? Okay, let's stare at the door. Is that what we're doing? Hi. Okay. Can I finish this? Yeah, for sure. All right, so we're going to read from left to right when we read a graph. Eyes on me, please. So let's say that you're standing right here. This is what I want you to do. Draw yourself right here. Draw yourself as a body. And you're going to go hiking. You need to describe to me if your hike is increasing to a maximum. Are you going up a hill to reach a really high part of the hill, then going back down? Or are you starting and going down a valley? Or are you going up a peak? All you need to describe to me is what's happening on your hike. Now think of the function or the graph as the mountain or the place or the terrain in which you are hiking. Luisa, can you sit up there? Sit up, sit up. All right, here we go. You're walking. La, 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 la. And now you're going to walk up or down a hill? Up a hill. Very good. Does that mean that your function is increasing or decreasing? Great. So tonight's homework, you're going to be able to tell me that it increases, reaches. Now I have to tell somebody if I reach the highest point of my hike, which we call the what? The maximum. Or did I go up a hill and reach the lowest point of my hike? Does that make sense? Go up a mountain and that's the lowest part of my hike?
No.
Doesn't make sense. Okay? So tonight I'm going to expect you to look at a graph and tell me if this is an absolute maximum or minimum. And then you're going to use a word other than maximum or minimum to describe the maximum or the minimum. Okay? All right. Sometimes you can go on a hike. Copy this down, please. Sometimes you can go on a hike and there's neither. There's no maximum, there's no minimum. And this is what something would look like if there's no maximum or minimum. Use your colors, please. Tiffany's going to come around and check. I want these colors. I have my 3 degrees. I already know this. What, babe? Middle? Sorry? There could be a midpoint, but there's no, like, maximum or minimum. And I'm going to explain to you why. I'm sorry. All right, here we go. As soon as you try to tell me the highest point of your peak of your hike, let's say like you're like, Miss Riad, look how high I was. Oh my gosh, this is how high my peak was. Your hike. I'll be like, well, there's an arrow here. Doesn't that mean that you were also over here? And over here? And over here? And over here? Like, the arrow means something. It's not there for decoration. The arrow is there to tell me that it's continuing. So as soon as you try to tell me there's a maximum, I'm going to beat you to it, be like, well, what about over here? That's why there's no maximum. Can you say the same logic for a minimum? Can you use the same argument for a minimum? I'm not convinced. Can we use the same argument for a minimum? Yes. Because as soon as you tell me that this is your lowest point on the hike, I'll be like, well, what about this point? What about this point? What about this point? So there is no minimum. Is everybody with me? You guys focus on me, please. Is everybody with me? So something like this graph, has no maximum, no minimum. Y'all with me? Tonight's homework, you'll be expected to take a graph and describe to me if there's an absolute minimum, if there's an absolute maximum, or neither. Let's go back to Desmos. Then you guys can start your homework. We're going to look at last night's homework, and we're going to describe whether these functions have absolute minimum, maximum, or neither. When you're ready to describe If there's an absolute minimum or maximum, raise your hand. There's arrows on the end. Be careful. You don't see the arrows, but they're there. When you're ready to tell me if there's minimums and maximums, you let me know. Annette, can you tell me if there's a minimum? No, you can't tell me, or no, there's no minimum? Yes, there is no minimum. Moises, is there a maximum? What would your answer be, Stephen? Neither. Very good. What would this be? Minimum, maximum, or neither? Wait, espérate. This one.
Maximum.
Don't yell it out, don't yell it out, don't yell it out. I want to know who knows. Raise your hand if you know. If you don't know, you need to ask a friend. You don't get to opt out in here. So you need to ask a friend if you don't know. You don't get to just sit there. Ask somebody if you're not sure. Go, Jaden, tell me. There is a maximum. Who got maximum? Nicely done. Luisa, do you see how this is the very top of your height? Good. How about this one? I know, this one's tricky, but think. I believe in you. What do you think, Ben? There is a maximum? Where? Oh, but what's here, but you can't see it, but it's there. There's an arrow. So do you still believe that there's a maximum? What do you believe there is? There is a minimum? Where? Huh? Neither. Can you walk me through why you first thought there was a minimum so that we can help other people in our car? Why do you think there was at first? Because what did you think was the minimum? Right here, right? This 3, but isn't this below 3? And this is below, and this is below? So the answer really is what, Louisa? Is there a maximum? Is there a minimum? There is? So is there a maximum? Is there a minimum? So then we have neither. Very good. Do this one by yourself. This is your doyo. Write it down. Draw the picture and tell me if it's maximum, minimum, or neither. All right, check your answers with each other. Decide if it's a maximum, a minimum, or neither. Are you guys all agreed? Jaden, what did your group say? Minimum. Very good. Now, can we just add one more word in front of that minimum? I mean, like, what it means to be. What we need to add is the word absolute minimum. Okay? Absolute minimum, absolute maximum. That's not scary, is it? It's exactly what we've been doing. Because a minimum and a maximum, what if a graph goes like this, and there's many of them? So you have to say the word absolute to describe the one that you see. Make sense? All right. Next thing I need to go over is to take out your books. And please turn to tonight's homework, number 82. We're going to do the second part together. What do you guys think about that? I think so. You're going to write what I write in your book, but then you're going to transfer it into your comp book for tonight's homework. Let me say that again. Right now, you're going to write what I write in your actual book. Then when you get to tonight's homework, whatever we wrote, just copy it into your copbook. Easy? Because it's only one word. Jose, read the directions for me.
Determine whether each graph represents a linear function, a quadratic function, an exponential function, a linear absolute value function, a linear piecewise function, or a constant function.
I love it. Thank you for trying those words, because some of these words we haven't seen before. So the fact that he read it out loud and really tried, thank you so much for doing that. All right. This is going to be kind of like a description of your hike, or you might describe it as like somebody you met and oh my gosh, I kind of like him, I have a crush on him. So this would be a relationship where you meet him. Remember, we read a graph from left to right. You meet this person and you're like, oh, she's cool, she's alright, she's kind of cool, she's alright. And then all of a sudden, boom, I really like this girl. Okay, that's the description that we use for an exponential function. Write that down. When something is chilling, all of a sudden, boom, like that, that's called exponential. If you're not sure how to spell the rest of it, can you look at the directions? It's up there in the directions. Exponential. That's 82. He's in the wrong chapter. You can just write exponential. Thank you for asking. All right, the next type of function. We're just going to go over them today. What kind of love story is this? This would be like a love story of, wow,
It was nice.
I really like this guy. And then like, he didn't text me back. Like, why is he on Instagram and he ain't texting me back? Oh, for sure, you're going to be on Twitter. Okay, Fortnite is more important than me? All right, for sure. This is like slowly but surely. Didn't drop like a what?
He didn't cheat.
Drop like a what? No. What's the graph that drops or goes really high? Very good. Exponential. Exponential is all of a sudden. Right? Exponential means like something happened and we're done. Right? This is like slowly but surely just kind of going downhill. It could also be slowly but surely going uphill as well. This kind of graph is called linear. Write that down, please. The next story. This will be a love story where, at first, he's kind of cool. Like, I like him. Brought me flowers, okay. And then, the honeymoon's over, and now, what does this mean right here?
He started playing Fortnite a lot more.
No, that would be like this. What does this mean?
Then you both play Fortnite.
Took a break would be like, there's nothing there.
You both played Fortnite.
But that's a great observation.
They forgot.
One of them went to Africa to go out.
If
The other one went to Mexico to go look at his grandparents.
Camden, what do you think?
They still like each other the same way.
Yes, it's just cool, right? It's not like I like him more than I did yesterday. It's just cool. It's cool,
Okay.
right? But it's not like I like him less either. It's just cool. We use the word constant for that. It's just constant. Wait, don't put constant because this part is constant only. And then stop staring at the door. And then now it's like summertime and I get to spend more time and then it goes back up. Okay? This right here has a very easy name. It is called piecewise. It's easy to remember because it's cut in pieces. Like, it's easy. If you're not sure how to spell it, it's in your directions. Can you put some? You can do it. Oh, yeah. All right, the next type of graph looks like this. This probably more accurately describes any high school relationship. Lord Jesus help you guys. This is probably why you shouldn't be in a relationship at your age. You guys are like this. I love him, I hate him. I hate him, I love him, I hate him. Who is he? I want to hit him. Well, you guys are all over the place. At your age, I was like, wait, didn't you just break up with him yesterday? I know, but I like him. I was like, huh?
He cheated on me 5 times.
I was like, stop talking. All right. This would be kind of like, I meet somebody, this happens sometimes, right? You'll meet somebody and you're like, oh, I really don't like him. Like, we don't get along.
Oh my god.
You ever met somebody at first you like fought and then you guys got along? You never had that happen to you? Yeah, it happens all the time. So this would be a description of somebody that at first you're like,
Quick hands.
I'm not really feeling this person at all. Then something happens. Then something happens and now we're cool again. Okay? This type of graph, and it can go vice versa as well. It can face down. Okay? This is called a quadratic. Turn the page. Let me do the last two with you. We just described this one. You meet someone, and it's just cool. Cool.
Parallel.
Cool. Look at your choices in the directions, because I feel like you'll be able to see which one this is. Do not yell it out when you figure it out. Do not yell it out. Do not yell it out. Dillinger, what do you think?
Horizontal.
Horizontal?
Something like that.
I like that. But if you could please look at the directions, you will have a choice. Go back a page, puppy. You have a choice on which one it could be. Hannah? It is constant. Nicely done. So this one is constant. Si haces la tarea, pero quieres hablar y hablar y hablar, pero no quieres hacer la tarea. Qué bueno.
I like it.
Malo. Oh, y'all gonna learn some Spanish up in here. Okay? Yes, eso. All right. You're lucky I'm not teaching in Arabic. One day I should do an Arabic lesson and see if you guys understand it.
I speak Arabic.
I'm Egyptian.
I speak French.
Last one. I speak American. All right. The last one. Please highlight this graph. Highlight that for me. And you're actually making a letter, don't yell it out, when you highlight it. It's just upside down. What letter did you just draw, Camden? A V. Good. It is a V. Oh, I know, but there's arrows. There's arrows, right? You guys, why are you racist? There's arrows. Don't ignore the arrows, okay? They're there, all right? The easiest way to remember, whenever you have a V as a graph, redraw the V, and it's called absolute value. V. Absolute value. Okay? I would love to answer a question right now. Yes, sir.
So anytime there's like a V-shaped line, it's automatically absolute.
Beautiful. Anytime it looks like a V, the shape tells you that's an absolute value equation. Yep. Give me a summary, please. Today I learned